You are welcome to Solo for Math. In this episode, we are going to look at a solution to this item from Mengo Senior School. As you see it was the beginning of term exam, Senior 5. Let's read through the item. It says 3 school clubs, drama, science, and maths are raising funds for a joint event. The following information is noted by the treasurer that the total amount of money raised by all 3 clubs is 600,000 shillings. The science club raised 50,000 less than the drama club, and the product of the amounts raised by the drama and maths club is 250 squared times the total amount contributed by the 3 clubs. The teachers of these clubs also added their contribution, and it was found out that the drama, this was supposed to be drama, the drama, science, and maths teacher contributed 2/5, 3/4, and a third, respectively, of what their respective clubs had contributed. So, like, the contribution of teachers was of the total amount that each club contributed. So, for example, the drama club contributed 2/5 of the total amount that the club contributed. Help the club patron to find out the exact amount of money that was contributed by each teacher, given that no club contributed more than twice the other. We're going to answer this. This was item or task 1. Part B, Josephine is helping her community to set up solar panels in a rural village. Each panel generates power based on a formula. We have an exponential formula. P equals to K into 2 to the power 0.5 T, where P is the power output after T hours of sunlight. K is the constant depending on the panel type. She installs one panel and observe that after 4 hours of sunlight, the output is 40 watts. So this is a question calling application for indices and logarithms. So items, the tasks are here. After how many hours will the panel produce 160 watts? Then how much power had the power produced after 1 hour? We are requested to write the answer in the form of root A. So we're going to give expected responses to this item. Let's start. Task A, that is requiring for the contribution of every teacher. This is how we go about it. We want to help the club patron, to find out the exact amount of money that was contributed by each teacher, given the number of club contributed. Given that no club contributed more than twice the other. So this is our task. We want to know the amount of money contributed by each teacher. So the values needed, we need the 600. You remember they told us that the total of the contributions by the 3 clubs is 600. So we need the 600, we need the 50,000. It was mentioned in the scenario. We need the 250 squared. We need these fractions because these are the contributions, partial contribution of each teacher in respect to their contribution of their clubs. So we begin by we're going to work with these variables. The first thing is let the variables that we are going to use, but define them properly. We don't just write X equals to drama club, Y equals science club, Z equals mathematics club. No. Let X represent the contribution by the drama club, because what we are looking for is the contribution by the drama club, contribution by the science club and math club. Then that will help us to get the contribution of the teachers. So we have to define this properly. What are we finding? The contribution. And that's what we let. This is what X is all about. The contribution by the different clubs. Now then, let's create relationships between these variables and then the values given. When we read our scenario again, let me get back exactly here. Here we have the statement: the total amount of money raised by all three clubs is 600,000. So it means that when we add X plus Y plus Z, this gives us 600,000. This is what our first equation. We go back. The science club raised shillings 50,000 less than the drama club. So the science club, meaning the contribution of the science club, which is Y, was 50,000 less than that of the drama club. So if we know the contribution by the drama club, which we let to be X, then the contribution by the science will be X minus 50,000. This is what it means by 50,000 less the contribution of the drama club. Then, and the product of the amounts raised by the drama and mathematics club, that means X times Z, because X and Z are the contributions of the drama and then the mathematics club. So it means X and Z, a product of X and Z is equal to is 250 squared times the total amount contributed by the three clubs. So is 250 squared times the total amount. The total amount was 600,000 contributed by the three clubs. Now, this is the information that we've picked from the question, the scenario. That is enough to help us get the contribution of the clubs. Then after, we can come back and use the fractions to get the individual teachers' contributions. So you see, we've used this, we've found out this, we've found out this, we've so far used it. What is remaining is this. So now the task ahead of us is finding the value of X, Y, Z. So these are simultaneous equations. We simply formed simultaneous equations. You looked at simultaneous equations. So how do we handle this? The best method we can use here is substitution method. We are simply going to substitute. So I'm going to first get equation 2 into, and I substitute it into equation 1. So if we substitute, what do we get? We end up with X plus the Y was our second equation as X minus 50,000. Let me first put this in brackets. plus the z, this is equal to 600,000. If we try to simplify this, this will be like 2x minus, we just add x plus x, minus the 50,000, then plus z equals to 600,000. So I can let z a subject of the formula here by taking every other terms to the right. So making x a subject gives me z as, this is 600 plus the 50 to be 650. Like this 50 comes, this is minus, so when it crosses it becomes positive, so it adds here and we end up with 650, and then minus a 2x, this one here. So we have our new expression for z as this. Okay, now this expression I'm going to substitute it in the third equation, here. Okay, remember it is an expression in x, so I'll get z, put it here, and then it means I'll have one equation in one unknown, and I can solve that then to help me get the other values. So if we substitute in equation 3, we end up with x into z. Remember it was xz, now z is 650,000 minus 2x, and this is equal to 250 squared into 600,000. All right, if we expand, this is a 650,000 x minus 2x squared equals 2. We are going to keep these values. Don't be quick at using the calculator. Let's first keep these values. We are going to see a reason why. Because if you try to use a calculator to find the value, it will be a very big value. So let's first keep them as small as this. Anyways, if we can see that there's a common factor here too. To try to reduce this, we can reduce by common factor 2, or I can even rearrange this to make it a quadratic equation. So I'll first divide through by a -2, divide through by a -2, divide through by a -2. Why have I divided by -2? I want to have, remember this x squared is going to be our first term, so I don't want it to be negative. Okay, so I will divide as I rearrange. So this becomes x squared, this becomes minus 325,000 x. Now this will be a minus, but since it is crossed by equal sign to this side, it will become a positive plus. Now this 2 will reduce this to 300,000. So it's like we have plus 250 squared times the 300,000, and this is equal to a 0. So we have a quadratic equation that we can solve to find the values of x. So further simplifying this will be x squared minus 325,000 x plus, now we can use our calculator here. And when you use your calculator, since it is a very big value, let's write it in standard form. It is going to ease our work. we expect you to get something like this. When you tap on your calculator, this is the value that you'll get. So for simplicity, we are going to use the quadratic formula, which says that our x, to get the value of x, it is a minus b plus or minus square root of a b squared minus 4ac over 2a. So we just identify our a. Our a is a 1 here. Our b is a negative 325,000. Our c is this, all of this. So we are going to substitute and then simplify to get the values of x. Yes, even this value here, we are going to express it as in standard form because we are going to apply it in this formula here. So for simplicity, let's also express all those big values in standard form. So that value will be 3.25 times 10 to power 1, 2, 3, 4, 5 to power 5. So we are going to use this instead. Since we also express this in standard form, it will be very simple for us, as you're going to see. So in substitution, our x will be equal to a negative b, but remember the b was negative, so we expect this to be positive. So we have 3.25 times 10 to power a 5. Okay, let me put it was a negative, but remember this b was also negative. So negative 3.25 times 10 to power 5 plus or minus the square root of b squared, which is 3.25, it's a negative, times 10 to power 5, this is squared, minus a 4 times a, which is a 1, times c, which is 1.875 times 10 to power 10. Now all of this is divided by 2a, but our a was a 1, so divide by 2. Now you see that these are big values. They're big values. So expressing them in standard form is going to help us so much. So let's simplify. Our first skip, this is a positive now, it becomes 3.25 times 10 to power 5 plus or minus. I'm going to first take out the 10 to power 5. Actually, the 10 to power 10, because now this has become 10 to power 10. If you look at this, 10 to power 10, we also have a 10 to power 10, so it is a common factor here. And since there is a root, we shall have a square root of 10 to power 10 out. And then what do we remain with in the bracket? We remain with the 3.25 squared. Okay, this one remains squared, minus 4 times 1.875. You can see how this has become a bit simpler. Okay, now we further simplify. This will be 3.25 times 10 to power 5 plus or minus, this remains 10 to power 5 times, oh, there was a square root here, I beg your pardon, there's a square root here. Remember there was a common square root, so we had forgotten it here. All right, so times, this is like a square root of, what do we get here? Use your calculator. It will give you 3.0625 over a 2. This gives us a 3.25 times 10 to the power 5 plus or minus. This is 10 to the power 5 times the square root of this is 1.75 over a 2. And if you are to simplify this even further, we can take out the common factor here, which is 10 to the power 5. See, I'm first dodging the calculator so that I simplify these values. Furthermore, here I remain with 3.25 plus or minus 1.75. Alright, now here, this is where we take a decision. Remember, we expect two values of x. If we use a positive, a plus, we shall get one value. If we use a negative, we shall get one value. So let's see what we get. If we use a positive, meaning if our x is equal to 10 to the power 5 over 2 into 3.25 plus 1.75, this gives us 10 to the power 5 over 2 times, this is a 5, and on dividing this becomes a 2.5, and 2.5 times 10 to the power 5 is 250,000. So one possible value of the contribution by the X club, the contribution by the drama club is 250,000. Now there's another value of x, that is if we use a minus, so 10 to the power 5 over 2 into 3.25 minus 1.25. This gives us 10 to the power 5 over 2 into a 15, a 1.5. Yeah, this is a 1.5. So on dividing, this is 10 to the power 5 times a 0.75, and this is equal to 75,000. Now we found the value of x. Remember, they gave us a condition that no one should contribute more than twice the other. So how do you conclude on that? Okay, let's find the contribution by the other clubs. The contribution by the drama club is either 250 or 75,000. So we need to be sure. We need one value, either this or this. So let's try finding the contribution by the other clubs. It will help us decide. So the drama club is sorted. Let's look at the science. Contribution of the science club. Remember, it was 50 less than the contribution of the drama club. Now let's test this. Let's use this to test. So if our x is 250,000, let's see our y. Our y will be equal to 250,000 minus 50, and this gives us a 200,000. Now look, if we have our x as this, and our y is as this, it means the x is beyond the y by just 50. It is less than twice. We have a condition that no club should contribute more than twice. I think we are still on point. Let's check the z. Now the z, of course, will be now the 600,000 minus the total contribution of x and y. Now the total contribution of x and y is 450,000. So when we subtract, we end up with 150,000. So this means, without even testing this, checking this, we can clearly see that these values meet our condition. The 150 is not more than twice this, is not more than twice this, and all other values are not twice the others. So we are going to take our x as this, the 250, and then of course the y is this, the z is this. Now these are going to help us to find the contribution of the teachers. So let's find the contribution of the patrons, the club patrons. The drama patron contributes 2/5 of the contribution by the club was 250. If we simplify, this gives us 100,000. The science patron contributes 3/4 of the contribution of the club, which is 200. And when we simplify, this will give us 180,000. Then math, which is a third, times the 150, and this gives us 50,000. So yes, these are the contributions of the club patron as requested by our task A. Now going back to our question, part B, each panel generates a power based on the formula that. So the first task is, after how many hours will the panel produce 160 watts? So the first thing we have to do is to first find K, given the necessary information from the question. So if you look at that part B, the values we need are, we were given a 4 hours, we're given 40 watts, and then we want to know the time consumed, the time taken to consume 160 watts. So we're going to first use this to find a constant K, because they told us that the power was modeled by, the amount of power consumed was modeled by K into 2 to the power 0.5 T. Now, if we substitute, when power is 40, the K is not known, but the time that was taken to consume the 40 was 4. So this can help us to find the value of K. So this is 40 equals to K into 2 to the power 2, which is 4. So it means our K will be 40/4, giving us a 10. So if we write our expression, it will be P equals to 10 times 2 to the power 0.5 T. So we are going to use this. Now, looking at this, the first part, Roman numeral 1, we want to know the time taken to consume the 160 watts. So P equals to 10 times 2 to power 0.5 T. So if our power is 160, it means when we substitute, this is this, and on simplifying, if you divide by 10 here, we remain with 2 to power 0.5t equaling to 16, but 16 is the same as 2 to power 4. We are now applying our indices here. So when we compare the powers, this will be 0.5, t equals to 4, and t will be equal to 4 divided by 0.5, which is equal to 8. So we conclude that the 160 watts will be consumed in 8 hours. Part 2. Part 2 is a question for the power consumed in 1 hour. So we're going to use the same expression, P equals to 10 times 2 to power 0.5t. So let's substitute. It means our t was 1 hour. So we remain with 10 times a square root of 2. So since they want our answer to remain in this form, the power consumed will be 10 root 2 watts. Alright, that is the expected response to this item. Thank you for watching. If you found this useful, kindly share, like, comment, and don't forget to subscribe. God bless you.